Hello everyone, now I'm going to talk about problem 1 for homework 6. X and Y have joint density function like this. Find A so that the above defined is a valid joint density function. According to the definition, we know that for a valid joint density function, the integral of the function in the definition area should be 1. So we may use the equation equals from -1 to 1 equals 1. So the answer is A equals 4. For part 2, are they uncorrelated? According to the definition, X and Y are called uncorrelated if and only if their covariance is 0, which means EXY equals EX times EY. The EX is the integral of x times fxy. It is x times this. It is 0. For EY, we use the same equation and we use the similar equation and the answer is 0. However, EXY is something like this. So they are not uncorrelated. Part 3. Are they independent? If they are jointly normal and uncorrelated, then they are independent. As shown in part 2, they are not uncorrelated, so they are not independent. Find the joint density function of x squared and y squared. We let z equals x squared and w equals y squared. And we just start our calculation. So the Jacobian of the transformation is something like this. So the domain of definition in the domain of definition, z in 0 to 1 and w in 0 to 1. Function is minus it is something like this. In this definition area, otherwise it is 0. So we get the conclusion. For part 5, prove or disprove that they are independent. According to the definition, they are independent if and only if F3W equals times for FZ equals we know that it is something like this. So FZ is this. Similarly, this. So FZ times FWW is this, which is exactly the value of FCW. So x squared and y squared are independent. Okay, and I want to add something about part 3. Are x and y independent? My answer is no. We may just use this conclusion, and we know that fx is 1 over 2, and fy is also 1 over 2. However, we have known that fxy, it is 1 plus xy over 4. So fx times fy equals fxy is wrong for every x from -1 to 1 and for every y from -1 to 1. Only in this situation, fx times fy equals fxy, but that's not meaningful. So x and y are not independent. This is the mathematical answer for this part 3. That's all for problem 1. Thank you for your listening.